So what we're going to do now is take a look at the idea of a limit, in that it's the behavior of a function as x heads towards something. Sometimes x is heading towards a particular number, sometimes it's heading towards positive or negative infinity, sometimes it's heading to the number from one side only. But before we get into that, we're going to look at just what does the idea of a limit mean. So we're going to look at a sequence of partial sums. And partial sums just means we're going to add numbers together and together. So I have two series on this sheet, series 1 and series 2. Each of them has a pattern. So for series 1, it's 1 over n cubed, where n represents the number of the term. So this one is 1 over 1 cubed, 1 over 8 is 1 over 2 cubed, and so on. That's going to be important because to get the sums, I'm really going to rely on my calculator and just write the answers down instead of having to start over each time. So partial sum means I'm going to add up to that term number. So term 1 means just add the first term. Well, there's nothing to add it to, and because the first term is 1, that answer is 1. Term 2 for this partial sum means add the first two terms, and it's going to be perfectly okay to work in decimals. So I'm going to, in my calculator, go 1 plus, I'm going to put it in brackets, 1 divided by 8. Because remember, fraction is just division. So that gives me 1.125. For term 3, I'm going to add 3 terms. So I could start over and go 1 plus 1 over 8 plus 1 over 27, or I already have the 1 plus 1 over 8 stored in my calculator. So all I need to do is now take that answer and go plus 1 over 27. And I get 1.162. 0.37037. Now we're not going to do any rounding because for a limit we want to try and find a very particular number. So I want to see as many decimals as I can. Term 4 means add up to 4 terms, but because this answer here is the sum of 3 terms, all I have to do is grab that 4th term and add it to that answer. So plus 1 divided by 64 in my calculator. 1.177662037. I'm going to repeat the process. Now, I could figure out what 5 cubed is and write it down to get the terms, but again, I'm going to let my calculator do the work for me. I already have the sum of the first 4 in there, so the 5th term is going to be plus, bracket, 1 divided by 5 to the exponent 3. So I'll let the calculator do the 5 cubed and the adding for me. So that gives me 1.185662037. To get the 6th term, I'm going to go plus 1 over 6 to the exponent 3. 1.190291667. I'm going to repeat that process down. I've already done it, so I'm just going to copy my answers over. So 7 is 1 decimal.
Please excuse this interruption. Would teachers please have their recycling bins sent down to the recycling area? Teachers, please have a student take your recycling bins to the recycling area. Thank you.
So the 7th term is 1.193207119. 8th term is 1.195160244. The 9th is 1.196531986. And then the next one is 1.197531986. So now, if I look at the behavior, I'm going to summarize the behavior of this series. It looks like it's heading to a particular number. It started at 1 and then 1.12, 1.16, 1.17, 1.18, on and on and on and on. But if I look at it, it's really starting to get closer to 1.20. So as I add more and more numbers, I'm not getting a bigger and bigger number where it's just heading off to infinity. I'm actually converging to some number, a particular number, 1.20. So this would be the limit of series 1. I'm going to repeat the process for series 2. So now I'm working with this pattern here. So term 1 is 3. So the sum of one term is just 3. Term 2 is negative 6. So if I add those together, 3 subtract 6 is negative 3. the sum of 3 terms is going to be negative 3 plus 9, so it's going to be 6. So each time I'm adding in, I'm taking my negative 3 and then I'm adding 9. To get the fourth, I'm going to take my 6 and add my 12. So that's going, sorry, my negative 12. So that's going to be negative 6. And now I'm going to keep the process going. So I have negative 6 in my calculator, and the next term is going to be positive 15, because really I'm just adding 3 each time, and the sign is changing. So negative 6 plus 15 is 9. So then 9 minus 18, because the next term would be negative 18, would be negative 9. Then I'm going to add 21, would be 12. Then I'm going to subtract 24, which would be negative 12. Then I'm going to add 27, which would be 15. And then I'm going to take away 30, which would be negative 15. That one, it was actually easier just to generate the terms in my head rather than going through and doing them. Now, if we look at the behavior for series 2 as we keep adding, this doesn't have a pattern. It's going positive 3, negative 3, positive 6, negative 6, positive 9, negative 9. So this is not converging to one number as we go. So this one does not have a limit. Each time I calculate a new sum, it's like I'm getting a brand new answer that is not heading towards a number in particular. It's just going to keep getting bigger positive, then smaller negative, and so on and so on. So this one, the limit does not exist because the behavior of the function does not converge to a single point. So now we're going to take that to the idea of a function, not just working with a sum or a series where we're adding numbers. So function 1 is f at x equal negative 1 over x subtract 2. And we're going to look at what's happening as x approaches 2, because we know x can't really be 2 for this function, because that would give us a bottom or a denominator equal to 0, and division by 0 doesn't work. You can't do it. So x is going to approach 2 beginning with 1.5. So I'm going to do 1.5 and then incrementing by a tenth or 0.1. So 1.6, 1.7, 1.8, 1.9. I can't actually go to 2 because if I put it in, I'm going to get an error message because that will give me 0 on the bottom. The other ones will just give me close to. So now I'm going to use my calculator and I'm going to calculate this out. I'm going to make sure to put brackets around the bottom because I have to tell my calculator that that is the bottom. So I'm going to do negative 1 divided by bracket, 1.5 minus 2, close the bracket, and that gives me 2. Negative 1 divided by bracket, 1.6 minus 2, and that gives me 2.5. Then I'm going to get 3.333. Then I'm going to get 5, and then I'm going to get 10 if I repeat the process. Now, this doesn't give me a lot of information because it's not looking like it's heading towards a number. So to try and figure out exactly what's happening, I'm going to put it in my calculator with as many 9s as I can after the 1 or the decimal place. So I'm going to do negative 1 divided by bracket 1.9999999. Just get as many as you can in there. Subtract 2, close the bracket, and in my calculator I get 1 times 10 to the 12th. So this is scientific notation, so it means there would be 12 zeros after my 10. So the important thing here is it's huge. These numbers were getting bigger, but they weren't getting bigger drastically. But the closer and closer and closer I get to 2, the bigger the numbers get. So as x approaches 2, f at x becomes really, really large. So it is heading towards infinity. So in this case, we would say the limit as x approaches 2 would be infinity, because as x approaches 2, f at x becomes extremely, extremely large. It's going to be getting bigger and bigger and bigger. So the limit for this function would be infinity. So if I were to graph it, I would have an asymptote at x equal to 2, because x can't be 2, and it would be approaching positive infinity as we got close to 2. Function 2 is I have f at x equal negative 2x squared plus x minus 4. Now there's no obvious holes in the domain, and by that I mean x's that we couldn't use. We can sub x's into here. There's no denominator, there's no division by 0, there's no square root where we can only root a positive, but I'm still going to investigate as x becomes large. Throw out my f at x on my first table of values. So as x becomes large, I'm just going to use multiples of 10. So I'm going to do, in my calculator, again, I'm going to let it do the work, negative 2 times 10 squared plus 10 minus 4 is negative 194. Negative 2 times 100 squared plus 100 minus 4 is negative 19,904. Negative 2 times 1,000 squared plus 1,000 minus 4 is negative 1,999,904. So I can already kind of see what's happening. You could put in 10,000, but you're going to have an even smaller number. The reason I'm saying smaller is because we are in the negative. So the larger this becomes with the negative, the actual smaller the number becomes. So this looks like as x becomes large, or as x heads towards infinity, the limit is heading towards negative infinity. We're getting smaller and smaller negative values that are just going to be getting more and more in digits as we go along. So this one heads off to negative infinity as x approaches infinity. This is a square, it's going to open down, so from my knowledge of quadratic, that makes sense to me. As x gets bigger and bigger and bigger, my function f at x is going to get lower and lower and lower and head towards negative infinity. So I have a very similar sheet for you to do. The sequences and the functions are slightly different, but I would like you to repeat this process and then submit your work to the Dropbox.